Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from National University of Singapore Paper Debugger, a plugin-based multi-agent system for in-editor academic writing, review, and editing. Large language models are already part of how many of us write papers, brainstorming, polishing paragraphs, even drafting responses to reviewers. But most of these tools sit outside the editor. You copy text out, paste it into a chatbot, then paste the result back. That constant context switching breaks your writing flow, and it makes it hard to track what changed, why it changed, and how your document evolved over time. Paper Debugger is designed to close that gap. It's an in-editor, multi-agent writing assistant that plugs directly into Overleaf. Instead of treating the model as a separate website, Paper Debugger brings critique, revision, and even literature research into the same window where you write your LaTeX. The goal is simple: keep you in the editor, keep the document as the source of truth, and make AI support feel like a natural part of the writing process. Under the hood, Paper Debugger is a full-stack system. A Chrome extension injects the user interface directly into Overleaf. Behind that, a Kubernetes-based backend spins up and coordinates different language model agents as isolated containers. Communication is handled through a protocol layer that streams results in real time. On top of this, a model context protocol toolchain connects to services like literature search, reference lookup, and document scoring, all exposed as tools that agents can call. The architecture is organized into 5 layers. The presentation layer is what you see in Overleaf, a floating panel and inline buttons next to selected LaTeX spans. The backend layer manages authentication, sessions, and routing through a gRPC gateway. The agent layer runs 2 kinds of agents: lightweight prompt template agents for quick tasks like grammar fixes, and workflow-based agents that coordinate multiple model calls and tools for deeper tasks. A protocol layer handles structured, streaming communication, and the infrastructure layer, built on Kubernetes, databases, and proxies, keeps everything scalable and reliable. Here's what happens when you actually use it. You highlight some LaTeX in Overleaf and choose an action, like critique or enhance. The extension packages that selection together with project context and sends it to the Paper Debugger server. The orchestrator decides which agents to run, maybe a reviewer agent, an enhancer, or a research agent on the extra MCP server. Those agents run in parallel where possible, call external tools if needed, and then return structured outputs. Finally, the system converts those outputs into deterministic before-after diffs that stream back into the editor, ready for you to inspect and apply. Paper Debugger isn't just a single model rewriting text. It's built around Extra MCP, a refined version of the Model Context Protocol tailored for academic writing. Extra MCP exposes a curated set of tools for tasks like literature search, affiliation lookup, and structured data extraction. Each tool is wrapped with Pydantic-based schemas and consistency checks, which helps keep outputs grounded and reduces hallucinations. This design lets agents chain together retrieval, analysis, and rewriting in a controlled way. On top of Extra MCP, Paper Debugger runs several specialized agents. A reviewer agent provides structured feedback, similar to a conference review, but focused on specific segments. An enhancer agent rewrites and refines text while respecting the surrounding context. A scoring agent evaluates clarity and coherence, giving you a quick sense of quality. A researcher agent performs literature lookup using the retrieval tools. All of this is powered by ExtraGPT, a suite of models tuned specifically for academic writing, so the suggestions match scholarly tone and scope. Let's look at a typical editing workflow. Suppose you're revising a conference paper and a section title feels unclear. You highlight that title in Overleaf and add it to the Paper Debugger panel. From there, you choose whether you want critique, refinement, or another operation. Paper Debugger then runs a pipeline of agents, a critic, an enhancer, and a patch generator, and returns candidate revisions as before-after diffs. You can inspect each suggestion, read the rationale, and apply the one you like with a single click. No copy-paste, no juggling tabs. This slide shows the in-editor patch workflow end-to-end. You can see how selection, request, agent processing, and diff application all happen inside the Overleaf interface, turning a simple highlight into a transparent, agent-driven revision loop. Paper Debugger also helps with heavier tasks like writing-related work. You can highlight a section header and request deep research. The system runs a multi-stage semantic search over archive and curated datasets, then re-ranks results with an LLM. It returns a ranked list of relevant papers, complete with metadata, abstracts, and short explanations of why each paper matters to your work. If you pick one and choose Compare My Work, Paper Debugger automatically extracts key aspects, like goals, methods, and datasets, and contrasts them with your manuscript, helping you position your contribution more clearly. Here you can see an end-to-end research scenario, deep literature analysis, retrieval of relevant papers, and a section enhancer all working together. The idea is to let you understand, compare, and refine your academic content without ever leaving the editor. Paper Debugger isn't just a prototype. It's deployed through the Chrome Web Store and used in real writing projects. Between May and November 2025, the system saw 112 installs and 78 registered users, with 23 users active in a typical 30-day window. Users created 158 overleaf projects and nearly 800 writing threads through the tool. The Chrome Store rating sits at 4.9 out of 5, with comments emphasizing the convenience and seamless integration into existing workflows. Telemetry shows that users lean heavily on iterative refinement rather than one-shot generation. The diff view is the main control surface. Users open diffs over 1,000 times in the sample period, compared to a few hundred copy or patch insert actions. Sessions typically contain multiple refinement events, suggesting that people are using Paper Debugger as a continuous editing companion rather than a one-off generator. This pattern aligns with the design goal of supporting thoughtful, controlled revision inside the editor. Putting it all together, Paper Debugger closes a long-standing gap between document editors and AI writing tools. By living inside Overleaf, it keeps full document context, structure, and revision history available to the agents. The same system supports quick line edits, structured reviews, and deep research workflows. Early deployment and telemetry show that researchers not only try it, but keep using it across multiple projects. For anyone writing technical papers, this points toward a future where the editor itself becomes a hub for rich, agentic assistance. If you'd like to experiment with these workflows, you can install Paper Debugger from the Chrome Web Store and connect it to your existing Overleaf projects. The authors note that, for this very paper, AI was used only to polish language, not to generate scientific content. Full policy details and a demo video are available in the project's GitHub repository. The broader vision is clear. Make advanced multi-agent AI support feel like a natural, trustworthy part of everyday academic writing.